Hey guys, today we're going to look at Staxrip. It's a video encoding program. It's able to do quite a bit of things, but today we're going to look at hardware encoding using Quicksync. So a couple of things you're going to need are, the first one is the Staxrip program. I'll include a link in the description. It's free. It's on GitHub. And the other thing you're going to need is just the video file you're going to use to edit. I'm going to use a sample file called Jellyfish. It's just a file that's there in a ton of bit rates and formats online, and so it's just pretty easy to work with. Once you have your video file available and Staxrip open, first thing you're going to want to do is just drag the video onto the Staxrip window. It's going to look into the file. One thing that's going to happen as it's reading the file is that it's going to create a folder based off of the file name and put it in your cache directory. By default, that cache directory is going to be in the folder that the video file is in. I've set my cache folder to be in my cache drive, a separate cache drive, and so that's where my video information is going to be. If you look in that cache folder for the file that I dragged in, you'll see a bunch of scripts, and as you're encoding as well, there'll be some temporary files that'll show up. For the purposes of this recording, we're going to be using Quicksync, and so we're transcoding that video, that the Jellyfish file that was in H.264 to H.265. And the benefit of using Quicksync, or just really any hardware encoder, is that it's going to be significantly faster and use much less power. It's going to be pretty light on your CPU as well. Staxrip includes a variety of options for encoding, both software and hardware encoding options. One of the other encoding options is NVIDIA. Well, it's actually NVENC, but it shows up as NVIDIA on that drop-down menu. But my NVIDIA encoder is being used right now for recording this recording right now. So we're going to stick with Quicksync for now. Once you've clicked the Intel H.265 encoder in the drop-down menu, you can click encoder options and it'll open a new window that, what a shock, shows encoder options. So it actually has a lot of settings, and I don't know what all those settings do, a lot of them at least, but I'll just go over a few that I like to use. So for the mode dropdown, there are a lot of options. I like to stick with intelligent constant quality. Variable bitrate can also be nice. So when setting the quality, the higher the number, the lower the quality, the lower the number, the higher the quality. And I'm not exactly sure why they did it like that. This codec that we're using, H.265, also this applies to H.264 as well. You're going to lose video quality as you compress. So as you encode, you're going to lose video quality. What matters is if that video quality is really perceptible for the uses that you're using it for. You can have it lossless, but that's not how it's typically used. What you want to do is balance file size with quality, and so try to get the highest quality value that you can have, and that'll correlate with the lowest video quality that you can get away with, but also lowest file size. 23 can be okay. I just like to be on the safe side and set it a little lower than the default. I like to put about 16 to 18, but I suggest you just experiment with different values and see which values you can get away with. You can also change the preset option, and the trade-off there is that the higher the quality, the slower the encode, and the worse the quality, the faster the encode. It'll still likely be faster than a software encode, like if you used X265 or X264, but it's speaking relatively. It's also speaking in theory as well, because I've worked on different files before, and when changing these preset options, I haven't always found a discernible difference in quality nor file size, but your results may vary. And I don't always go pixel peeping. I usually don't go pixel peeping. So if I don't see a difference in quality on the face of it, then I don't really look into it too much. One option you're going to want to change is the decoder setting. By default, it's set to avsynth/vaporsynth. And in my experience, that is a software decode. So when you're trying to transcode, it'll decode using your CPU. Depending on how complicated your file is or how processor intensive your file is, that can really hammer your CPU. When you're trying to transcode, you are decoding a file and then encoding it to another codec. And your transcode is only going to be as fast as the slowest link in your chain. If your decoder ends up being the slowest link in your chain, it's going to slow up your whole transcode, slow down your whole transcode. Using software encode is generally slower than using fixed function decoders that are built in a lot of CPUs or GPUs. And so you're going to want to set that to a hardware decoder. So there are two options that I'm okay with using. There's the Quicksync hardware option and also the DXVA2. Just check each one and see which one works better for you. Since this tutorial is for Quicksync, I'm going to use Quicksync hardware decode. Sometimes if you restart an encode that you aborted earlier, it's going to ask if you want to reuse or re-encode. And pretty much what it's asking is if the output that was there, that's already there in your cache folder, is the complete transcoded video file. So if you aborted it in the middle, it's not your complete video file. And so you're going to want to click re-encode. Once the encode is started, one thing you're going to notice is that your CPU usage is going to be pretty low. So you're not burning up electricity as you're doing these encodes. My Intel GPU isn't exactly the best one on the market, and so you're going to notice that the speeds aren't really that fast, but they're still relatively fast compared to software encode depending on the CPU you have. And obviously, like I said, it's very power efficient too. As you can see, after the encode is done, a new file pops up in the folder of your original video file. It'll have the same name followed by an underscore new. The video file size of the H.265 encoding is smaller, which is what you would expect. H.265 is able to produce smaller file sizes for equivalent quality compared to H.264. You may be wondering if there's any downsides to using a hardware encoder like Quicksync, and there are a couple downsides. One of them is that the file size to quality ratio is generally considered to be worse for hardware encoders. And the other drawback is that software encoders like X265 tend to be much more customizable and give you way more options than, well, I'm not necessarily way more options, but it gives you more options typically than hardware encoders like the ones in NVIDIA, AMD, or Intel GPUs. If you're willing to sacrifice quality for speed, or you don't want some of the customizations that X265 or other software encoders may provide, then hardware encoding may be the best option for you. And you also get the benefits of hardware encoding like speed and power efficiency. So hopefully that was an easy to understand tutorial on how to transcode video in Staxrip using Quicksync. If you have any questions, just post in the comments. Thanks for watching.